Hello everyone, welcome to lesson 9-4, direct variation. For more information, you can look at pages 405 to 410. Let's look at the example. The term varies directly with the term number. So the term varies, right? It varies directly with the term number. If we look over here, we have the term and the term number. So the term and the term number. The term is the one that varies. So if the term is the one that varies, this is our dependent variable. And our independent is the term number because the term is the one that varies. And it varies directly with the term number, as you see. So if this is our dependent and this is our independent. Write an equation that relates the term number with the term. Then find the 16th term. Okay, so we have here our x and our y. And you can see our y is whatever our x is multiplied into. See that? So if we have 1 and it equals 9 on this side, if you replace it, okay, then m equals 9. As you can see, we simply replace the variables. M is often used for slope. Okay, for slope, when we write the equation of the line or y-intercept slope, we use m to define the variable as the variable for slope. And you'll see later on that we can graph these equations. Okay. Now you can see here where we can plot them on a graph. Use m to write an equation. So y equals 9 times x. So we just replace x. And 9 times 16, because we wanted to find the 16th value. Replace x with 16. Remember earlier we did the first value with x, right? Now we're trying to find the 16th. So the 16th, the y place would be 144. Okay? The 16th term is 144. So notice that we use the variable that we chose, okay, or the information that was given to determine what m means. Now m is what's being later replaced, okay, as the equation as the value. You can see that we replaced it with m, and we were looking for the 16th term. Over here we solved for the first term, and we said the first term is 9, right? Well, here the 16th term is going to be 144. Okay, if this doesn't make sense to you, please read it through carefully, see how all the variables have been replaced. And here we have the independent practice. We have questions 14, 15, and 16. Simply 3 questions. Let's look at the first one. The cost of renting a paddle boat varies directly with the number of hours. So the number that varies, remember, is our y. Okay? The number that varies. So what is varying? The cost. The cost is varying, and there it is, our y. Okay? And it varies directly with the number of hours. Okay? Depending on the hours, the cost will change. Makes sense, right? And here we have 2 hours is $18, 3 hours is $27. I can see that my unit rate is 9. Do you see it? Okay, that's our unit rate, because if 2 is 18 and 3 is 27, 4 is 36, 5 is 45, 1 must be 9. Makes sense, right? Okay, now let's answer these questions based on this information. Write an equation that relates the number of hours with the cost. Very similar to what we did here in the example, boys and girls. I think I'm going to leave this as it is because I think you'll be able to figure it out. Okay? Find the cost of renting the paddle boat for the 7th hour. Now, use the 7th hour, figure out what the m is up here, the way you did here, and then replace, then write the equation when you solve over here, just so we did with the 9, and then replace the 7 or the x with the 7, okay, and multiply. All right, and then give 16 a try, and we will look at it in class. Something I want to point out to 16 is this. You see this little line here? What we've done is we couldn't draw all the lines. We didn't want to waste space because our data doesn't start until 62. So because we didn't want to waste space, we crunched it. And all this means is that we've squeezed in a bunch of numbers in here, and we've just gone ahead to the higher numbers, the ones that matter. Okay, the data. That's what this symbol means. Okay, go ahead and try this independent practice on your own. Lesson 9-5, slope-intercept form. Now we're going to start graphing these equations, as you can see by the example. Please take a look at the explanation, read it through carefully. Okay, I know that you can read all of these steps and make sense of them, so do that on your own, but I'm going to go right ahead and jump to the example. This is what we call the Y-intercept slope. Okay, we have our slope, which is always rise over run, and it's over 1. And we have our y-intercept right there of -1. So what does this mean? We often we may not be given an equation this way. We may be given an equation where it says y minus 4x equals -1, and we have to move it around so that it looks this way. We can practice that in class, and you'll see what I mean. But how does this apply to our graph? Okay, take a look here. The slope of the graph is 4, and the y-intercept is -1. Okay, that's what this means. We've labeled these. Okay, m is our slope, and -1 is going to be our y-intercept. So when we graph, it looks like this. Okay, we start with our y-intercept slope, which is telling us that we have to start. Remember, this is our y. This is our y-intercept. So this is the y-axis. So we start by finding where -1 is. There it is. Okay, there's our -1. I'm just going to go ahead and mark it red. And then from that point, we have to use our slope and figure out our slope. Remember that our slope is always over 1. Okay, it's over 1. And this is rise over run. Okay, we can write it like this, where 4x over 1 is the same as your rise over your run. Now your rise is how much you're going to move up or down, rise. And your run is how much you're going to move horizontally. Okay, so rise, run. So, and we're starting from our y-intercept slope, which is -1, as you see right there. We started from -1. Now we're going to count. Okay, our rise is 4. 1, 2, 3, 4. And our run is 1. You see it? Run is 1. So we run 1, +1, and we move over 1. So we count 4 from this point. 1, 2, 3, 4, and we run 1. So that's our second point right there. We can connect those 2 points, and we have our slope. There's our slope. As we said, our slope was 4. It is 4. 4 over 1. You see that? 4 over 1. Rise over run. What if we wanted to go the other way? Well, we just change both of them to a negative. Change this to a negative and change this to a negative. I did that right here, by the way. I don't know if you're watching. I changed this to a negative and this to a negative. So now that means that from this point where we started, I'm going to now rise, or I should say now this time descend, go down by 4. 1, 2, 3, 4, and -1. -1 is to the left. And that would be our other point. And you see how it still matches? Okay, and we can still draw our straight line right through. And there's our y. So our y equals this. This is why it's a solid line. Okay, our y equals this. Let's look at the independent practice. We have 17 to 28. 17 to 28. For numbers 17 to 22, state the slope and the y-intercept of the graph of each equation. Simply identifying. So our y-intercept here would be +7, and our slope is 4. 4 over 1, right? But you can just simply say 4. And how would you write this? Well, since you're being asked to identify first the slope and then the y-intercept, your answer will be 4, semicolon, 7. Because you're answering both. Your slope is 4 and your intercept is 7. Okay? Here, what is your slope and your y-intercept? Do you have a y-intercept? Okay? Notice that you don't, so it's 0. But in your slope is -4 over 3. And your y-intercept is 0. Okay? Remember how I told you too that sometimes you have to move things around? So this 5x has to come over to the other side so that it looks like the y-intercept form, so that it looks like equation 17 where y equals 2 terms, where you have your slope and your... So this is your slope. Your slope is 5 on this side, but if you bring it over the equation to this side, it's going to become -5, right? It becomes the opposite. So -5, so y equals negative 5x. So if it equals negative 5x, your slope is negative 5. And what's your y-intercept? Well, there's none. It's just 0. Okay. I hope that kind of makes it clear of what you have to do here. Remember, this negative x has to come to the other side, and it becomes positive x minus 8. Okay. Over here, you've already got it set up in the y-intercept slope. Over here, your y-intercept slope is a negative slope. It's a negative slope. What you could do first is multiply everything by the negative 1, so it becomes positive, because we have to have this positive. And then what does it become? Well, this this is negative, on the other side it's going to become positive. What I mean is this, boys and girls. We can't have a negative variable. How can we change this to a positive? Well, you have to multiply the entire equation by negative 1. Negative 1, if I multiply this by negative 1, it'll turn it to positive. So if I do that, then this becomes negative 4x plus y equals negative 6. You see? Okay? Now that I've done that, I can move this negative 4x to the other side so that it looks more like this. I know I'll just have my y left, so y equals, I move this to the other side so it becomes the opposite, so now it becomes 4x positive, it was negative on the other side, minus 6. Okay, so what's my slope? My slope is 4 and my y-intercept is 6, and that's your answer. For questions 23 to 26, you're being asked to graph each equation using the slope and y-intercept slope. I want you to graph these. On your piece of paper is fine. If you have grid paper, even better. But if you don't, you can simply make it like this. Let me just shrink this over here. I don't mind if you go ahead and just draw y and then x. Use a ruler, please. I can't use a ruler because I'm using my finger. And then put your increments or your, and if you just do it like that, I'm happy on your piece of paper. And over here we have negative x. It rises a negative 1 over 1, so it's negative 1 negative, oh, but our y-intercept is 4, so it starts at 4. 1 2 3 4, so our first one starts there at 4. And then I'm going to count rise is negative 1 and run is negative 1, so it goes this way. I mean positive 1. Negative 1 over. Okay, let me just show you. This is our equation. Okay, this is our equation. As I mentioned, it's negative, but it's over positive 1. Okay, so if it's negative, after I've already found my y-intercept, 1, 2, 3, 4, there it is, I go down by 1, and over positive 1. I guess negative, down by 1, positive 1. And there's your slope. You could draw your line right through there. You can keep going. You go another negative 1 and positive 1, negative 1, positive 1, and you keep going and you draw your line. Alright? That's all you have to do for those 4. And it's nice that they're already all 4 in the y-intercept slope. Go ahead and try number 27 on your own. Let's do 28 together. Jacob is ordering DVDs from a website. The site charges a flat rate for shipping. Okay, a flat rate means just a rate that charges everybody no matter what time or where it is, the rate. Okay, that's the price. It's a flat rate. No matter how many DVDs he buys. The total cost, y, that's the cost, of Jacob's ordering is given by y equals 9x plus 5. Okay, so y, don't forget, is our dependent variable. And we choose our x. Where x represents the number of DVDs he buys. Right, we get to choose how many DVDs he buys. State the slope and y-intercept of the equation. Describe what they represent. The slope. I see that the slope is this is our y-intercept slope, right? And this is our slope. So our slope is 9. And because the x represents the number of DVDs, right? And it's going to be multiplied by 9. Okay? And then the y represents the total cost. So this y represents the total cost. The y-intercept is the second number. So 5 is the y-intercept. And we have to describe what they represent. So what they represent is the slope represents the cost of each DVD. Okay, this is the cost of each DVD, and x is the amount of DVDs we're going to buy. And the y-intercept represents the shipping fee. Okay, this is the shipping fee that's being added so that we know how much it costs. Okay, so that's what it represents.